The average length of time for the patient to register for the admission ward has been 45 minutes. A new registration procedure using modern computing machines of being tried. If the random sample of 10 patients have an average registration time of 30 minutes, with standard deviation of 10.8 minutes under new system, test the hypothesis that the population mean is now less than 40 using 0.01 level of significance. Assume the proportion of time to be normal. In solving hypothesis testing for population mean, there are 6 steps. First step, null and alternative hypothesis. HO, in this problem, HO, M is equals to 30, and HA, M is less than to 30. Step 2, you need to identify the level of significance, and the level of significance in this problem is 0.01. So HA is directional. Hypothesis test is one-tailed. Appropriate test is t-test. And step 3, you need to identify the critical region. A is equal to 0.01, T is equals to 2.621. T is less than to negative 2.621, and the DF is equals to 9. Step 4, compute for Z value. T is equals to 30 and minus 45 divided by 10.8 divided by square root of 10 is equals to negative 4.39. Step 5. In step 5, you need to decide if accept or reject. Since H is accepted, since it is within the critical region and greater than negative 4.39. Step 6. In step 6, this is the conclusion. The average length of time for registration is 45 minutes. Problem number 2. A random sample of 130 recorded deaths in the Philippines during the past years showed an average lifespan of 80 years, with a standard deviation of 7.7 years. Thus, this seemed to indicate that the average lifespan today is greater than 72 years. Use 0.05 level of significance. To solve this problem, we have 6 steps in solving this. Step 1. Null and alternative hypothesis. HO, M is equals to 72 years. HA, M is greater than 72 years. Step 2. You need to identify the level of significance. Level of significance is A is equals 0.05. HA is directional. Hypothesis is one-tailed. Since standard deviation is unknown but N is greater than 30, then the appropriate test statistic is Z test. Step 3. Critical region. Z is greater than Z level of significance. Z is greater than Z 0.05. Z is greater than 1.96. Step 4. Compute the Z value. Mean is equals to 80 years. Standard deviation is 7.7 years. N is equals to 130. 80 minus 70 divided by 7.7 divided by square root of 130 is equals to 11.76. Step 5. You need to decide if it is accepted or rejected. Reject HO since the computed value of Z is within the critical region which is greater than 1.96. Step 6. Conclusion. The average lifespan today is greater than 72 years. Problem number 3. A sport equipment has developed a new treadmill that has a mean braking strength of 8 kilograms with a standard deviation of 3.2 kilograms. Test the hypothesis that M is equals to 8 kilograms against the alternative hypothesis M is not equals to 8 kilograms if a random sample of 35 lines is tested and found to have a mean breaking strength of 6.2 kilograms. Use 0.01 level of significance. Step 1. Null and alternative hypothesis. HO, M is equals to 8. HA, M is not equals to 8. Step 2. You need to identify the level of significance. Level of significance. A is equals to 0.01. HA is non-directional. Hypothesis is two-tailed. N is equals 35 appropriate. And the appropriate test statistic is Z test. Step 3. Critical region. A is equals to 0.01 or equals to 1%. CI is equals to 99%. CV is equals to 2.576. Step 4. Compute the Z value. Z is equals to mean minus M0 divided by S divided by square root of N. 6.2 minus N is divide 3.2 divided by square root of 35 is equals to negative 3.33. Step 5. In step 5, you need to decide if it is accepted or rejected. HO is rejected since it is within the critical region and less than negative 3.33. Step 6 is the conclusion. The sport equipment new treadmill average is not equal to 8. In fact, it is less than to 8. Thank you. This is Elizabeth Tor from ABM N5 together with Jocelyn Lawas and Christine Bacunawa. Thank you, Miss.